All right. We will do number 4 and 5, I think. Unless I change my mind. Where did my chalk go? My pocket. All right, did you guys at least read number 4? P is a point on the parabola y equal x squared. Write the distance between P and the point 31 as a function of x. So what you have to do is you have to read it, read this verbal description, and then write a function from it. Then you're going to have to use your calculator to compute the maximum or minimum point, which we did in polynomial chapter. But now these functions can come out to anything. It doesn't have to be a polynomial. So number 4. We have, and again, all of these problems you're going to see in calculus, whether you are in A, B, or BC. Except next year you're going to use calculus to solve it instead of your graphing calculator. Okay, here is a parabola y equal x squared. Here is the point 3, 1. So if I put this problem on the quiz, I'll just probably change that point to like 4, 1 or 5, 2 or something. Okay, here is a point on the parabola. How do we label a point on the parabola? X, y. But then look, y equal x squared. So you can label it x comma x squared, right? That's just substitution. You can substitute now or substitute later. So what we're going to do is we're going to write this distance as a function so we can graph it on our calculator. So how do we find the distance between 2 points? You use the distance formula. Square root of x minus x squared plus y minus y squared. That's your function. So sometimes it's easy to write the function, but then sometimes it gets harder. You got to use like similar triangles, Pythagorean theorem, or something else even. Most of the time similar, I don't know, the similar triangles are the ones that give students the most trouble. Okay, so all you have to do now is graph this on your calculator, and you should see something, well, if you graph it on the appropriate window, you should see something that looks like this. So there is a point there that's a minimum. Because think about it, when you take the distance from this point to the parabola, there's all kinds of distances, but isn't there a shortest distance? That's what we're trying to find, the shortest distance. And then in fact, what are we trying to find? It says find the point on the parabola. So we need to find this point right here that's closest to this point. Okay, so you go to your graphing calculator. So those of you watching on video, I guess you just gotta pretend you're looking at the graphing calculator. Okay, I'll bring mine up. Boom. Okay, so go back. Some of you are in advanced graphing. Go back to regular graphing. Function. Punch in the function. So what is that? Square root. Okay, we're gonna concentrate here. Square root of x minus 3 squared. Parentheses x minus 3. Right arrow squared plus parentheses x squared minus 1 quantity squared. Right arrow square, get out of the radical. Enter. Double check to see if it's right. It is right. Now what kind of window should we use here? Because some of you just want to press the plot button. I know already. I've been teaching this 34 years. Set your window. It's better. You guys got to learn that, you know. So in other words, x min, x max by y min, y max. Okay, now x represents the x coordinate of this point. So shouldn't it be like somewhere in between here? Right? So 0 to 3 would be good. And then what does y represent? Like if you graph this, this is y, right? Y represents the distance. So it's not going to be smaller than 0, and then you got to kind of guess. I would say 10. Remember I told you start with 10, and if that doesn't work, then 100 and 1,000. Increase it by factors of 10. But it's up to you. If you think you're good enough, you can just press the plot button and go from there. And go ahead and do it, but I don't do it that way. So shift, plot, X. See, look, my previous window is all messed up. You don't know what your previous window is. 0, enter, 3, enter, 0, enter, 10, enter. Now press plot. Oh, see, you see a minimum point there? So how do I calculate that minimum point? Put the cursor somewhere near there, and then go menu, function, extremum. And there you go. So let me go back to the board. And I remember we had a problem like this on a previous quiz. A lot of you guys got points taken off. Can somebody read it to me so I don't have to go over there? What does it say? So when you graph this minimum point here is 290, comma 1 point. Okay, here. Too late, I'm going over here already. 1.2, 1.834. There you go. Okay, but you gotta answer the question. We want the coordinates of this point here. Okay, well, the x value is the x coordinate. So point P, the x coordinate is 1.290. Is this the y coordinate? No. Y represents the distance. This is the minimum distance between the 2 points. Remember you guys made this mistake last time. A lot of you made that mistake. So how do you get the y coordinate of the point on the parabola? Yeah, you square it. The equation of the parabola is y equal x squared. So you have to take this number and square it. So can I just go 1.290 squared? No, never use a rounded value in another computation. So you have to take this number with all its decimal places and then square it. You guys remember that? Okay, so how do you get there? Remember I told you, once you compute this point right here, this number with all its decimal places is stored into x. This number with all its decimal places is stored into y. So all you have to do is go to the home screen, punch in x squared, and then that will give you the value. The calculator will automatically put in this value of x with all the decimal places and square it. Here, let me show you again. Okay, so you go to the home screen. See, look, I'll just press X. I'll just press X, enter. See how you got 1.289623901, all the decimal places? So now you just go X squared, enter, boom. So 1.663 is the answer. Never use a rounded value in another computation. Oh, just walking over there, I kind of forgot the numbers already. Was it 1.663? Oh, okay, my memory's not that bad. Okay, there you go. Make sure you answer the question now. Just because you find that point, you got to answer the question. All right, let's do one more problem and we're done. Which one? Oh, darn. Oh, I got to go back. Okay, let's do number 5. That's a fun problem. I guarantee you're going to see this in calculus. Oh, you probably can see this one in calculus next year, too. That's why I put it on there. I put all the problems that you're probably going to see in calculus. Okay, number 5. Let's see if you can understand this problem. From a raft, that's a scam. From a raft 50 meters offshore. So here's a beach, like here's a beach. And 50 meters away you have a raft. This is a raft, 50 meters away. A lifeguard wants to swim to shore. So he's in the water there. This is the shore here. A lifeguard wants to swim to shore and run to a snack bar. Here's the snack bar. that's 100 meters down the beach. The lifeguard can swim at 2 meters per second, but he can run at 6 meters per second. Express the total swimming and running time as a function of x, and then use your graphing calculator to find the value of x that will minimize the time. In other words, how can the lifeguard get from the raft to the snack bar in the shortest amount of time? Now, some of you might think, well, just swim the whole way there, because a straight line, that's the fastest, right? No, because you can run 3 times faster than you can swim. Now, if you could run just the same as you could swim, then probably just swim the whole way. But no, you can run 3 times faster than you can swim. So what should I do? Just come down here, perpendicular, and then run all the way there? No, there's got to be an optimal way of doing it. Probably you're going to swim to a point over here somewhere, except we don't know. So that's why do we call that x? And then run the rest of the way. That's going to get you the fastest. So what we want to do is find the value of x that will get the lifeguard there in the fastest amount of time. Okay, so what do you need to know? What are we trying to maximize or minimize in this problem? The distance? The time. Okay, so we want to write a function for time so that I can graph it on my calculator. Well, what do you have to know in this problem? Rate times time equal distance. Therefore, time is equal to distance over rate. Okay, so look at this picture. What is the distance that the lifeguard swims? Isn't it this right here? Well, if you know 2 sides of a right triangle, can you figure out the third? Yeah, you use the Pythagorean theorem. So wouldn't that be the square root of x squared plus 50 squared? Do you guys have that skill yet? Remember we did this in poly? And again, if you don't have that skill, use the box method. Call this box. Apply the Pythagorean theorem. Box squared is equal to x squared plus 50 squared. Therefore, box equals square root of x squared plus 50 squared. Okay, so that's the distance that the person swims. And then you divide that by the rate. What is the rate that the lifeguard can swim at? 2 meters per second. So 2. Distance over rate is time. So this is the time that the lifeguard spends swimming. Now we have to figure out the time that the lifeguard spends running. Well, what is the distance that the lifeguard runs? 100 minus x. Everybody agree? That's why you got to draw a picture. And then what is the rate? 6 meters per second. So distance divided by rate is time. This is the time that the lifeguard spends swimming. This is the time the lifeguard spends running. If you add them together, isn't that the total time? There you go. Okay, so you got to be able to get there. Now you graph this on your calculator, and you should see a minimum point. So there's going to be a time or a value of x where, so again, if you're the lifeguard, once you figure out where this point is, put a flag there or something. So every time you just swim to that point and run the rest of the way, right? So where is that point where you put the flag? Well, let's find out. So you go to your graphing calculator, punch in the function. See, the hardest part though is writing that function. That's why you guys gotta practice that. So go to symbolic, let's get rid of this old function. Shift, clear. Woo. Okay, here we go. Square root. I'm not really fast with this. X squared plus 50 squared. You guys want to write 50 squared, or you guys have the ganas to go 2,500? You guys have the ganas? Divided by 2, right arrow, and then plus, what do we got? 100 minus x, we need parentheses just in case. 100 minus x, right arrow, divided by 6. Enter. Let me take a look at that. Yep, that looks good. You guys know 50 squared is 2500, yeah? If not, just put 50 squared. Okay, now let's set the window. I know, see, some of you want to just plot. See, look, there's nothing on the screen if you just use the previous window that we had. That's why you should set the window every time. Shift, plot, set up. So what does X represent in this problem? The distance from the left edge to the point on the beach where the lifeguard wants to land. So, okay, obviously it has to be bigger than 0, but what about X max?
100.
Yeah, 100. How come X can't be bigger than 100? Because otherwise the 100 minus X would be negative, right? It's 100. Now what does Y represent? The time. So you can't have negative time, so 0 is good. And this is where you kind of have to guess. So we'll try 10 first. 10 seconds, I don't think that's enough. Why don't we just put in 100 to start with it, right? Because you're not going to get there in 10 seconds. Okay, now let's plot. Oh, yes, I see the minimum point. You see it? It's like on the left there, over here somewhere. So put the crosshair somewhere near the minimum point. Menu, function, extremum. What? No minimum or maximum found? That's impossible. What happened? Anybody know what happened? Function, extremum. What? Did I punch it in correctly? The square root to 200 minus x over 6. That's correct. Is that a comma or a decimal point there? You know what? I'm going to change it. No, it's not. It's right. Okay, we know that's right. So something is up here. And look, that is a minimum point, right there it is. Menu, function, extremum. Hey, how come now it gives it? Technology. Sometimes you just got to do it again. All right, so the coordinates of this minimum point are, oh, bloody, I can't see. 17.678. 17.678, and then the y coordinate is 40.237. Okay, now answer the question. Oh no. Somebody read me the problem. Oh, it is. Find the value of x that will minimize the time. So in other words, what is this distance here? Well, is this x? Yep, that's your answer. This is your answer. What if the question was, what is the minimum time in seconds? Then the answer would be 40.237 then, right? So that means the lifeguard should be able to get from there to there in 40.237 seconds, and that's the fastest that the lifeguard can get there. Anyway, so this is exactly what you got to do at tonight's homework. You write, and this is the hard part. You got to write the function, and then once you have to graph it on your calculator, that's the easy part, right? Hopefully. Now, some of these get pretty hard now. Again, you're going to have to know all your volume and surface area formulas now. If you don't know it, it's going to be painful. Like I told you, in calculus, you're not allowed notes. On the AP exam, you got nothing. Like in physics, you get a page of notes. In calculus, you got nothing. Everything got to be here. So why don't you guys just memorize it for life already? These volume and surface area formulas.